Ha! Alright, let's finish up some chemistry here. Part number 4, I believe. We'll talk about some lipids. Those are the fats. That's a very large and diverse group of organic compounds. They're mostly carbon and hydrogen, very little oxygen. This quality, this hydrogen and oxygen ratio not being similar to that of water, makes these molecules, since it's not similar to that of water, it makes this molecule insoluble in water. So those are known to be hydrophobic. Um, the easy visual is salad dressing. Oil and vinegar don't mix, oil and water don't mix, and the lipids will separate out. Our neutral fats are our triglycerides. Those are the fat deposits we have, the insulation. Those are energy sources, but those are also building blocks for other lipid substances that we use in the body. What they have is a glycerol backbone. That's the glycerol backbone back in here. We have 3 carbons that are attached, and then from those come fatty acid chains, 3 of them. And fatty acid chains are basically carbon, 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 carbon with some hydrogens attached to it. Many different types of length of carbons. The amount of carbons is one feature, but then also what is important is to note if there's single bonds like here, or if there is some double bonds like here. So the covalent bond is an important feature of the fats and oils, because if we have absolutely no double bonds in there, only these up here, we have what we call a saturated fat. And they are very nice parallel fatty acid chains that can be packed fairly solid in room temperature. And so saturated fats, saturated means saturated with covalent single bonds. That means they're all covalent single bonds. That fat is solid at room temperature. That's like butter or lard, for example. When we then go to the next one, the one that has 1 or more double bonds in them, we look at unsaturated fats, and those are oils at room temperature. They're not bonded enough that they're a solid, they're still a liquid. And olive oil is a very good example of that for it. And then we have, when we talk fats, we talk saturated fats, the so-called good, bad fats, and because unsaturated fats, we consider those the good fats. And then we have trans fats. And trans fats are really the bad fat. Because they originally they came as margarine and other baked goods, but now we have them in all different processed foods. They are partially hydrogenated plant oils. So they put more hydrogens on them, and that decreases their double bonds and makes more single bonds out of them, and that makes them more solid at room temperature. The reason why they're bad is because they really work against the cardiovascular disease. So the bad ones, the saturated and especially the trans fats, enhance the heart disease and blood vessel disease. All right, let's talk about this a little bit more. Prostaglandins are interesting local acting hormones, so they influence how the body functions. They need to be balanced. We have 3 basic families, prostaglandin 1, 2, 3s. They control many functions like blood clotting, blood pressure, inflammation, and more than that. The family 1 comes from plant oils. We call them PG1s. The PG2s come from red meat and dairy products. And the PG3s from cold weather oils and cold water fish. The prostaglandins like to be balanced. We need more of the 1s and the 3s, the oils and the cold oils and nuts, and we need less of the number 2s because we have plenty of those. And what those do, they enhance inflammation and they lead to many degenerative diseases such as cancer, diabetes, autoimmune disease, and heart disease. Trans fats go into that PG2 category, and the reason why they're so bad is that they don't just make more of the prostaglandins 2, but they also inhibit the production of the number 1 and the number 3 families. So we have a buildup of very inflammatory agents around in the body, and the environment of such is then established for a sudden onset and a cascade of inflammatory processes like a heart attack. And that can be very dangerous. And so I think it's important to understand to avoid the trans fats. And come on, who needs a pancake and sausage on a stick and dipped in chocolate chip? I don't know about that. But anyway, we have the phospholipids, and the phospholipids are composed of a glycerol with 2 fatty acids on one side, but now we have a phosphate group on the other side. That is very interesting because the fatty acid sides, giving us these fatty acid tails when we depict it here, or just these single lines, they are nonpolar or hydrophobic. And the phosphate end is polar and hydrophilic. So these molecules can be on one side in a hydrophobic environment, on the other side in a hydrophilic environment. This is a great material that we can use for making cell membranes, because we need a boundary between the outside and the inside of the cell. Well, what we do is 2 rows of basically phospholipids pointing the nonpolar tails at each other, and the hydrophilic heads on the outside. That makes us basically a film, a hydrophobic oil film between the 2 heads that can stay in a water environment. And that sets up a nice boundary that does not let be crossed by hydrophilic molecules. Only hydrophobic molecules can go through. Cell membrane is the phospholipid bilayer is also referred to an elementary membrane. Steroids are important. They are flat molecules. They are fat, but they look very different. They look like they have 4 interlocking rings. So they are mostly carbons and hydrogens. That makes them hydrophobic, and that makes them basically a fat. Cholesterol is the most important one that we have. It is the building block for many other molecules, such as vitamin D or sex hormones, also cortisol and aldosterone, which we'll learn more about it later. We also find it in the cell membrane. We have 2 types of cholesterol. One we call the good one, the other one we call the bad one. The LDL is a low-density lipoprotein. We call that the bad one because it carries fat molecules from the liver to the body. And the HDL returns fat back to the liver for processing, and that's why we call that the good one. All right, I guess I talk a little slow, so we'll do one more on chemistry.